Hello, welcome back to my channel. I'm so glad that my dogs are deciding to lose their cool as soon as I start this. But anyway, welcome back to my channel. I've actually thought about a name potentially for this channel. I might just leave it as my name and just kind of like use this as a title thing. But I already made an Instagram account with it, so if you're interested, definitely check it out. But it's called EnviroViral, so it might be a little cheesy. I thought it was catchy. Check it out, because that's my new thing. But I wanted to talk about some climate mitigation strategies, and I thought it'd be interesting and a cool way to quantify potential solutions. So let's get started. Okay, so I wanted to talk about something that's been developed by the Princeton Carbon Mitigation Initiative, and it's called climate stabilization wedges. So what are they? They are ways that we can quantify climate mitigation and certain behaviors that we can adopt to stop our current rate of greenhouse gas emissions. So if we were to stop increasing the amount of CO2 that we're currently adding to the atmosphere, then the CO2 trajectory would flatten into a straight path, a flat path into a straight line, creating the wedge above it of the previous trajectory, and that wedge is called a stabilization triangle. So this triangle is divided up into 7 wedges, so you can more easily explore different solutions to tackling each wedge, but each wedge grows from 0 to 1 gigaton per year of carbon over 50 years, totaling 25 gigatons of carbon per wedge. So if you want to reduce the amount of CO2 that we are emitting by 25 gigatons of carbon in 50 years, there's a certain amount of efforts that it would take for each wedge, or each 7 of those wedges, to be mitigated. So the effort needed by 2055 to tackle one wedge for nuclear power would require 700 gigawatts of capacity of nuclear power, and that is if it's displacing coal power. So that's about twice our current capacity of nuclear power generation. So there's all kinds of implications that might be associated with this, right? So you have to think about the amount of land that it would take, the risk, the technological developments that might be necessary. So that's one wedge. If you want to tackle 25 gigatons of carbon, using nuclear power generation, it would take 700 gigawatts. So in terms of wind, if we wanted to reduce our carbon emissions by 25 gigatons by 2055, we would have to add 1 million wind turbines at 2 megawatts capacity each. So that is on top of what's currently being produced. There's already wind turbines that are out there right now. We would have to add 1 million on top of that, and that's over 30 times our current number in capacity. I think my dogs are eating cat food right now. 1 second. I'll be back. No, stop it. Anyways, so in terms of wind power, what would the amount of land be that it would take for 1 million more wind turbines and stuff like that? There's so many other questions that you have to consider when tackling that wedge. You can go away now, Harley. In terms of solar power, it would take 2,000 gigawatts at peak capacity to, again, prevent 25 gigatons of carbon from being emitted by 2055. So that's over 500 times our current capacity of solar power generation. So solar panels obviously take up space. They have to be in certain areas, and it's estimated that that amount of capacity would take about 2 million hectares of land to achieve that. So that's another thing that I want to address potentially in a later video, is power density. So power density has to do with how much electricity or power is generated by different kinds of energy production. And it's easy to rank different kinds of power generation as either high like they have high power densities or they have low power densities. So something like coal has a very high power density per land area because coal power, burning fossil fuels, generates a very high amount of electricity and of energy rather. And solar panels, however, take up a lot more land and they still generate less power. So solar has a low power density. So when you're thinking about increasing your energy production to 2,000 gigawatts of solar power, you have to think about how much land it would take to displace the coal energy that's being currently produced. So another climate stabilization wedge, another triangle that has the potential to reduce 25 gigatons is power from carbon capture and storage. So we would have to capture 800 gigawatts, which is over 30 times our current number and capacity of carbon capture and storage. So the technology might still have to be developed for things like this, and it raises a lot of questions. Another solution is efficient use of electricity, particularly in like buildings and things like that. So we would have to reduce our consumption of electricity even as the population is increasing, even as we need more and more air conditioning because it's getting warmer, even as other countries are becoming more and more affluent and are able to afford things like air conditioning units and stuff like that. So you have to consider how hard it would be to reduce consumption before you can like quantify, you know what I mean? Obviously, I'm just asking this camera a question, but anyway, it's a really hard thing to tackle because it's easy to say, okay, yeah, we can just reduce our consumption of energy, but there's going to be more people in the world. There's going to be different standards of living, and that's something that's just hard to talk about. So another potential wedge that can be tackled, you already know, 25 gigatons of carbon for each wedge by 2055. So we could double our fuel efficiency or cut our driving distances by 50% for 2 billion cars. So there's a couple different examples of how this could work. So I'm just gonna go through those really quickly. 2 billion cars at 5,000 miles per year at a 60 mile per gallon efficiency could help achieve this wedge. Or 1 billion cars that drive 10,000 miles a year at a 30 mile per gallon efficiency could also be another way to tackle it. It just depends on whether you want to cut the distance or increase the fuel efficiency. There's different ways you can tackle it. Or you could do 4 billion cars at 5,000 miles a year and 60 mile per gallon efficiency. So there's tons of ways that you can start to tackle these wedges. One wedge can be tackled by combining different strategies. Of course, you could use some wind, some nuclear, some efficient fuel usage, and some solar power, and that could all add up to 25 gigatons of carbon. But obviously, there's a lot that we need to do to prevent future warming. And there's also some challenges and critiques of climate stabilization wedges. So people ask sometimes if the strategies are gonna get used up, which means that let's say you want to tackle climate change with wind, building wind turbines and using wind energy. So is the first million turbines going to be easier or harder than the second million? So is the first wedge or the second wedge going to be harder? Is the second going to be harder because you already know what you're doing, or did you already use up all the land? You have to think about the land question always. And the first million, maybe they'll have more favorable sites for building wind turbines on them, and the second million, maybe they'll have benefits from experience or advanced technology, and maybe you can generate more energy per turbine in the future. It's just only time will tell. So I also wanted to mention this project. It's called Project Drawdown. So there's a book called I think it might be called Project Drawdown. I'll link it or something below, but they came up with 100 solutions to bring down our CO2 concentrations. And I want to go into some of those a little bit more in detail in a later video, but they include things like direct air capture of carbon, regenerative agriculture, things like silvopasture, things like that, decreasing food waste or increasing distribution at least, and alternatives to cement or marine permaculture, things like that. And this project drawdown, they show the implementation costs of each strategy and the net operational savings, and they rank each one according to basically how achievable or realistic or important it could be to preventing future emissions, but that shows how much CO2 would be reduced by each action. And some of the things are things that you can do at home, like recycling and things like that. So definitely check out drawdown.org, and I'll probably talk about that in another video, but I hope you enjoyed. I hope you learned something. Thanks for coming back. Subscribe, come back, and I'll see you next time.